So in these Ferris wheel problems, right, this is a sinusoidal motion, as in the person is going around in a circle. And if we plot the height of the person with respect to time, we get a graph that looks like a sine graph, aka a sinusoidal graph. Okay, so here are some things that we need to be able to put on your graph that I'm going to be looking for when I go to grade these. Number one, we should be marking your horizontal axis. Okay, this is of course your time axis. And the most important part of the time is its 1 revolution. So we're going to come on here and we're going to say 1 revolution happens every 70 seconds. So somewhere we come over here and we put 70 seconds representing the time of 1 revolution. Okay, 1 revolution is also known as your period. So this graph, this sinusoid has a period of 70 seconds, right? And we're going to need that in the future to write our equation. Okay, but we need to use the b value. So we'll talk about that in a minute. Some other things that we need are this minimum, right? The bottom of the wheel is 8 feet above the ground. So this is your height axis. So we're going to put our first tick mark there on the y-axis and call it 8. That is our first height. And now we're going to put 2 more that involve the radius. So we have a radius of 40 feet. So if the bottom of my graph is at 8 feet and I have a radius of 40 feet, that means the middle is where? Very good. The middle is at 48. Okay, if you take your minimum and you add 40 to it, 8 plus 40 is 48. And then what is the maximum height? If we add another 40, we get a maximum height of 88 feet. Okay, so the 88 on top, this is your maximum, right? We're not going to ever go higher than 88 feet. And 8 on the bottom, this is your minimum, which means 48 has to be your middle. Okay, which is a good thing to have for our equation later. 48 feet is the middle. Okay, so if we were going to make this sketch, we're going to do our horizontal midline right through here through 48. So that's the middle of our graph, representing, of course, the center axis of your Ferris wheel. So some other things we need, right? We know that we start at the bottom, so we put a dot here on the y-axis at 8. Okay, we start at the bottom of this graph. And if we have a sinusoid, that means that after 70 seconds, we're going to be back at the bottom. Okay, if it takes 1 revolution, you return to where you start after that amount of time. So if we start at the bottom, after 70 seconds, we're back at the bottom. Which means exactly halfway, which is 35 seconds, we're going to be at the maximum value of 88 feet. And because this is sinusoidal, halfway between there, we're going to be at our midline, and then halfway between the middle and the end, we're going to be at our midline again. Right? These are the 5 points that we need to graph all of these sinusoids, in this case, a cosine. So we want to connect these dots with a smooth curve. Right? Hopefully you're not on a herky-jerky Ferris wheel ride and it's nice and smooth. Right? Smooth rides mean less people fall out, which means no lawsuits for the company. So make a nice smooth line, and this represents the height above the ground of any given time t as you go around this Ferris wheel. Okay, so this is the first thing that we need to do is graph it. We need to have some labels on your x-axis where you have your period and then your middle point. We need to have your minimum, your maximum, and your middle. And then you need to have the dots at the appropriate places. Okay, so this is the graph of the path of a person who started at the bottom. And we're going to use this information to write an equation. Okay, write an equation. So write an equation of the height above the ground as it starts at the bottom as a function of time. So you can either write a y equals equation, or we can write it formally, right, using notation, function notation, the height given time. So t is your independent variable, height is your dependent. So if you want to write y equals, that's fine also. So some things here. Our graph starts at the bottom or at a minimum. Which of our 4 equations is best if your graph starts at a minimum? Good answer. The answer is a negative cosine graph. If your equation or if your graph starts at a minimum value on the y-axis, then the best equation is a negative cosine graph, because a negative cosine graph won't have a phase shift. So negative cosine, notice I left a space in there. Well, the space is for the amplitude. The amplitude of your graph is the same as the radius of your Ferris wheel. The amplitude of your graph is the same as the radius. So our Ferris wheel has a radius of 40 feet. So we put 40 as the coefficient in front of cosine. And now we turn our attention to the period, or in other words, finding the b value. Okay? Remember, period equals 2 pi over b. 2 pi over b. We need our b value for our equation. So b equals 2 pi over period. And this period is 70 seconds. So the b value for your equation is 2 pi divided by your 1 revolution time, right, your period. So 2 pi over 70 reduces to 1 pi over 35. We're going to multiply that by t. Okay, it's very important that your variable goes inside with your b value. Since there's no phase shift, we're going to leave it right in there. And the last thing we're going to be concerned with is the vertical shift, aka the midline. So the middle of our graph is there at 48. Okay, so these are the things that constitute our equation. We have the radius, we have your b value from your period, and we have the midline. These are the 3 things that we need to have in there. Plus, it's a negative cosine, because our graph starts at a minimum. So if you have that done correctly, the next problem is pretty easy. Use this equation to find the height of the rider after 40 seconds. So we're trying to find the height of the rider after 40 seconds. Okay, so this is a calculator problem. You just stick all this into your calculator, replacing t with 40. Replacing t with 40. So 40 seconds. Let's look at our graph. 40 seconds is a little bit past halfway. So we should be expecting a height somewhere around 88, right? Between 85 and 88 feet, I would think, would be our expected height, right? 40 seconds is really pretty close after 35 seconds, so we should be on the way down, right? Our answer should definitely be less than 88 feet. But probably more than 80 feet. So let's see. Stuffing all this in our calculator, let's see what we get. 84.03875 or 84.0388. We'll put 88 out there. Or 039. I already can't see that. But these are in feet, right? The units here are feet. Okay, part D, here is the algebra portion. When is the first time, right? When we're asking is a time question. So we want to solve this equation for t, for time. When is the rider 20 feet? So that's the height. We're going to put 20 right here equals negative 40 cosine pi over 35t plus 48. So we replace h with 20, and we have our entire equation with t as our variable. Okay, this is the algebra portion. We want to solve this equation for t. So our first step is to subtract 48. Right, if we want to solve for t, we have to get all the things away from t, and the first thing we do is subtract 48. So negative 28 equals negative 40 cosine pi over 35t. Our next step is to divide by negative 40. Okay, be very careful when you do this in your calculator that you have a negative divided by a negative, right? Because the positivity matters. 0.7, or if you have a fancy calculator, you're going to get 7/10. But 0.7 is the same thing as 7/10. Pi over 35t. So now we have a number equals a trig. Okay, so we can't get rid of our parentheses. You can't touch the pi or the 35 until we get rid of the cosine. So our next step is to move cosine to the other side by doing its inverse. Okay, so you want to make sure that your calculator is in radian mode for this before you take the inverse cosine of positive 0.7. Okay, and we get a nice decimal, 0.795398, or whatever else your calculator says. Keep all those decimals in there. And so we're done calculating. Okay, so this is the trig part, right? We take the inverse cosine in order to get rid of the cosine. The inverse cosine cancels itself out. And our last step is to multiply by the reciprocal of your fraction. So we're going to multiply by 35, and then we're going to divide all of that by pi. Okay, so multiply your fraction times 35, and then divide that answer by pi, and I get a time of 8.86 seconds, right? These units are in seconds, so my answer is in seconds. It takes me 8.86 seconds to go from 8 feet, where I started, to 20 feet. Okay, so this is an important understanding that we started at 8 feet, and then after 8.6 seconds, or 8.86 seconds, I am now at 20 feet. Okay, that's important to understand. Because the next question says, when is the second time that I'm going to be at 20 feet? Okay, what goes up must come down. Of course, because of gravity. And we are assuming that this is going up and down at the same rate, right? Or it wouldn't be sinusoidal. So there's a lot of symmetry going on. If it took us 8.8 seconds to go from our minimum value to 20 feet, right? 8 is the minimum value. It took us 8.86 seconds to do that travel. It's going to also take us 8.86 seconds to get from 20 feet back down to your minimum. Okay, and this is an important understanding about these graphs of sinusoids, is that there's a lot of symmetry. So to find the second time, you're going to take the 70 seconds, which is your next time, where you're going to be 8 feet, right? That's your another minimum. At 70 seconds, you're at another minimum value. And if we subtract the 8.86 seconds that it's going to take from you to get from 20 feet to your minimum, that's going to tell us when the second time is that we are at 20 feet. Okay, and that's going to happen at 61.14 seconds. Okay, the first time you use your calculator, right, it's an algebra question. The second time you're using your understanding of sinusoidal graphs, because your calculator won't give you a second answer if you're plugging in 20 again. Okay, so that's important to understand, that we are going to subtract your first answer from the next time you reach a minimum. right, because of the symmetry of these graphs. Well, hopefully your brain has been refreshed, and you will be able to do this tomorrow on your test. All right, that is all. Goodbye.